This video corresponds with Lesson 6 of Unit 4A, dealing with how to rationalize denominators in radical expressions. As referenced in the previous lesson, when you have a division problem, you're allowed to have radicals in the numerator of a fraction. However, you cannot have the radicals in the denominator of a fraction. So, sometimes, as you saw in the previous lesson, sometimes the denominators simplify out very nicely, and you don't have to worry about the radical. However, there's plenty of combinations where the radical won't simplify out right off the bat. We have to come up with a strategy in which to get rid of that. That's what this process of rationalization does. So we're going to take a look at a couple basic problems where we have to just rationalize the denominator with one radical. And then we're going to take a look at a couple of problems where we have to use something called a conjugate in which to get rid of the radical in the bottom of each of these fractions. So let's take a look at these first two here, where these are more basic fractions. So first and foremost, let's say I want to take the square root of 4 over 3. Well, you learned in the basics of how to simplify radicals. We can take the square root of one big fraction and split it apart so that the numerator and denominator is being square rooted separately. So we can take the square root of 4 over the square root of 3. Well, we know the square root of 4 is 2, which is nice. But square root of 3 doesn't go anywhere. Doesn't simplify down. We can't make it magically disappear. You're not allowed to have that radical in the denominator. So in order to get rid of it, we have to use this process called rationalization. What that basically means is this. In order to make the radical in the denominator disappear, I'm going to need to multiply my current answer by the denominator that currently exists over itself. Now you're probably thinking, well, why do we do that? Think of it this way. If I focus on solely just what I wrote here, the square root of 3 over square root of 3, if I simplify that down, that's the exact same thing as multiplying by 1. And as we know, multiplying by 1 doesn't technically change the value of whatever answer we're dealing with. While our answer is going to look different than what we currently have, by doing this rationalization process, taking the denominator and multiplying it by itself, top and bottom here, by doing this, it's going to clear the denominator of a radical. It's going to look a little different, but it's going to have the exact same value. So what I'm going to do here is, by multiplying by square root of 3 over square root of 3, multiply across, because that's how multiplying fractions works. Top would become 2 square root of 3. In my denominator, if I have square root of 3 times square root of 3, we know that becomes square root of 9. But when I take two square roots of the same number and multiply them together, it just becomes that number underneath. Square root of 3 times the square root of 3 just becomes 3. That is our final answer. There's no radical in the bottom. It's okay that there's one up at the top, but we've now rationalized our answer and written it in a way that is acceptable. Second problem is the exact same idea, only difference is of the way that I split it apart here. So, there are a couple ways you can go ahead and do this. What I would suggest is to try to simplify, again, whatever you possibly can within the problem. So just in looking at this here, we can't do anything with square root 7. But in the bottom, square root of 20, that's going to break apart into square root of 4 and square root of 5. So I can rewrite this as square root of 7 over top of 3 times 2 square root of 5, which would then equal square root of 7 over 6 square root of 5. Now the reason I'm simplifying it first, because I want to see, maybe I can simplify it the whole way down, maybe get something to cancel out, and I don't have to rationalize. If anything though, you'll notice in this case, I still can't get rid of the square root in the denominator, but if anything, I made the number at least smaller to work with. And again, the whole goal is to make these as small as possible, as simplified as possible. Sometimes you'll luck out and get things to cancel. In this case, we don't. So we rationalize. Now, when I want to rationalize my denominator here, all I'm going to focus on is the square root part. That's square root 5. Especially when it's multiplied together like this. We'll talk about the problems that numbers 3 and 4 in a minute, where we have to focus on more than just the square root itself. But I'm going to go ahead here, multiply by the square root of 5 over square root of 5, because again, that's just a fancier way of saying let's multiply by 1. It's going to look like the following. So the top would become square root of 7 times square root of 5, which is the square root of 35. In the bottom, I would have 6 times square root of 5 times square root of 5 is simply 5, which would give me a final answer of the square root of 35 over 30. And that would be my rationalized final answer. So when I just have to do basic rationalization, okay, all we're focusing on is the term in the denominator that's being square rooted, okay? When you take a look at these problems underneath for numbers 3 and 4, you'll notice, yes, we have square roots in the bottom of each problem, okay, in the denominator of each problem, but they're being connected by addition or subtraction. We can't just multiply by whatever the square root is because it won't allow all the terms to be affected equally. It doesn't work out the way that it should to clear the denominator. So what we have to do in both of these problems here is multiply by something called the conjugate. All the conjugate is taking whatever's in your denominator that has a square root. So for example, we have 2 plus square root of 7 in the denominator of number 3. If I want to make it go away, I'm going to multiply by the conjugate, which is simply just flipping the sign that's in the middle there. I'm going to multiply by 2 minus square root 7 over 2 minus square root 7. Because again, same thing top and bottom, it's just a fancy way of multiplying by 1. I'm going to multiply by the opposite of whatever's in that denominator here, and by opposite I mean we're just going to take the sign in the middle, change it from a plus to a minus. When we do this here, there's a lot of distribution, a lot of multiplying, combining some terms when we do this, but you'll notice the square root will go away in the denominator, and that is the ultimate goal. So I'm going to take care of what's up top here, and what might help you here is anything that's an expression with a plus or a minus, put parentheses around it, might help you in terms of distributing things correctly. That's up to you though. So I'm going to take the 12 and distribute it. So up top we're going to have 24 minus 12 square root 7. In the bottom we're going to have 4 terms. So the first thing we're going to do is distribute the 2. So 2 times 2 is 4. 2 times negative square root 7 is negative 2 square root 7. Now I'm going to go ahead and multiply the square root of 7 to the 2 terms after it. So square root of 7 times positive 2 is positive 2 square root 7. Square root of 7 times negative square root 7 is negative 7. Okay, again, put your square root of 7 times square root of 7. That's how we get the 7 itself. It's negative because one's positive, one's negative. Now, up in the top, there's not really anything I can do. That's just going to stay 24 minus 12 square root 7. There's nothing to simplify there. I'm stuck. But in the bottom, you'll notice my 2 square root terms, negative 2 square root 7, positive 2 square root 7. I can combine them together. They're opposites. They're going to cancel out. So all I'm left with is 4 minus 7. So I then end up with, if I continue to simplify, 24 minus 12 square root 7 over negative 3. Now in some problems, depending on what your denominator is, you may be able to stop at this step. However, you still want to look and see, will this simplify further? So if I take a look here at this first set here, if I try to do 24 divided by negative 3, that's going to come out really nice to negative 8. If I try to do the second grouping of terms here, negative 12 square root 7 divided by negative 3, that's going to come out to positive 4 square root 7. Again, the goal is to simplify as much as you humanly can. Some problems you'll be able to stop once you go ahead and get things to cancel out in the denominator of the fraction. Sometimes whatever your denominator is left over, maybe that divides nicely into your terms of your numerator. That, again, just depends on the problem itself. But you want to keep simplifying until you can't do anything else. But that's how we use a conjugate. So it's the same idea as rationalization. It's the fact that though we have something being added or subtracted with a root in our denominator, our process is just slightly different in terms of what we multiply by. Number 4 is the exact same idea. So again, all we're focused on is clearing that denominator to make the square root and it disappear. So if I have 2 minus square root of 15 in my denominator, I want 2 plus square root of 15 as my conjugate. And I'm going to multiply by that fraction over itself here. So once again, I'm going to go ahead and put lots of parentheses around things, lots of distribution, but again, do one layer of stuff at a time. So we're going to go ahead, distribute the 3. So I'll have 6 plus 3 square root of 15. And then I'll take the square root of 5 and distribute it. So that'll give me positive 2 square root of 5, positive square root of 75. Now I'll do the same thing in the bottom. So I'll distribute the 2. So that'll give me 4 plus 2 square root of 15. And then I'll distribute the negative square root of 15. So it'll give me negative 2 square root of 15 and negative 15. Now, from here, I'm just going to simplify as much as I humanly can. So this is going to get kind of messy here just because there's more terms now in our numerator that we have to look at. But first things first, in the numerator here, we break down whatever we can. So we have a 6, 3 square root 15. 15 only breaks down to 5 and 3, so I'm not going to worry about that. 2 square root 5. 5 doesn't break down at all. 75, however, breaks down into square root of 25, square root of 3. So if it helps, we can go ahead and just write it out like that. Okay, and we'll come back to that in a second. In our denominator, the middle terms cancel out, so I'm left with just 4 minus 15. Now, we're going to look at this. We're going to do one more wave here, simplifying. So up in our numerator, we have a bunch of different terms. So everything stays the same, except for that last term. So square root of 25 square root of 3, we can rewrite it as 5 square root 3 over 4 minus 15 is negative 11. And even though that's a really gross looking answer, that is technically the way you're supposed to write it. So some of these problems, depending on, again, the more terms that you have, especially in problems like number 4, where you've got an expression both the top and the bottom of your fraction, you're more than likely going to have messier looking answers. But it's all the same type of process. You simplify what you can, you combine like terms wherever you can. If you can divide stuff out, at least with this problem, dividing by negative 11 typically is not very nice, so we're not going to do anything more with this fraction. We're just going to leave it be. So, in short, that's how we rationalize denominators, use conjugates. Again, the goal with all these problems is if you're messing with a fraction, you cannot have a radical in your denominator. So this is going to be our set of processes here in order to get the radical to disappear.